To another edition of Sudoku Invariants, where I teach you how to solve Sudoku invariants the easy way. This will be a short tutorial pointing out a pointing pair. Oh, come on. Why is it doing that for? Oh, wrong one is why. Notice I attempted to circle the 4 and the 3 pair. Because there is only 2 squares that the 3 and 4 are in, and that only the 3 and 4 are in those 2 squares, we cannot have a 3 or 4 in any other square in the same row, because we would then have a square with no numbers in them. If I were to make this column 5 row 6 be a 3, and make column 6 row 6 be a 4, then this makes column 1 row 6 have no numbers it can be. Notice that we still cannot have more than one number in, let's say, notice that we still cannot repeat any number in any row, column, or 3x3 grid. And because we put a 3 in the wrong spot, this makes column 1 row 6 not have any valid numbers. This is why the 3, 4 naked pairs are called pointing pairs, because they point to the fact that no other squares in the same row as them can have a 3 or a 4. Now, if I were to make column 5, row 6 be a 4, we'd still have the issue of one of the naked pairs not being allowed to have any valid numbers in them. I cannot put a 9 there because there already is a 9 in that column. These naked pairs already had all numbers except the 3 and 4 ruled out. So I cannot just make up a number and put it in anyway. I'd be duplicating numbers within the same column, row, or 3 by 3 grid. Thus, I can remove the 3 and 4 from column 5, row 6. This makes the 8, 9 another naked pair. Thus, we have 2 naked pairs in row 6. Notice that the 3, 4 naked pair only rules out 3 and 4 out of the same row, as they are not in the same column or in the same 3 by 3 grid. The 8, 9 naked pair is also not in the same 3 by 3 grid or the same column. I cannot use them to remove 8s and 9s from their columns. Yeah. Three. If I were to make row 6, column 3, the 9, then that would dictate an 8 in column 5 and make row 4, column 3 have the 8. This is why I cannot take out the 8 and 9 in the first 3 by 3 grid in rows 4 through 6, columns 1 through 3. Okay, looking at row 3, we have a pointing pair, the 2-3 combo. Notice that there is only 2 squares that only contain a 2 or a 3. Oops, a 2 and a 3. In column 5 and 6, we only see a 2-3 combo and no other numbers in those squares at row 3. This means that the 2-3 cannot exist in column 6. If I were to make column 5 row 3 be a 2, that would force column 9 row 3 to be a 3. How could I make then column 6 row 3 be a 2 or a 3? I could not. If I were to make column 5 row 3 be a 3, then that would force column 9 row 3 to be a 2. That also forces column 6 row 3 to not be a 2 or a 3. This is why I can remove both the 2 and the 3 from column 6 row 3. This would make this square be a 6, meaning that I could remove 6 from the other squares in the same column, row, and 3 by 3 grid that the 6 is found in. And this concludes this tutorial. I am going to solve this Sudoku for real in another video and do it in order this time while trying to point out the various techniques. Thank you. Thank you for watching this tutorial with me. Let's see if I can get this where I want it. Please like, subscribe, and share. I hugely appreciate it. Thanks again and have a wonderful day. Bye.